we're going to talk about the segment addition postulate. So here it is. Here's your segment. And I'm just going to break this down. If you were to draw just a segment here, and you split this up into multiple pieces. So I'll call this my segment. I'll call this segment A and C. You could separate this and break this up into multiple segments by putting another point anywhere in here. I'll put this point B here. And I'll say that the entire segment is segment AC. That's the entire segment. And what did I break up AC into? I broke up AC into two more segments. I broke it up into this first piece here, which is segment AB, and then a second segment here, which is segment BC. So now the entire segment of AC is composed of two separate segments, segment AB and segment BC. Can I make this into more segments into two segments? And the answer is yes. Okay, but we're going to focus on two segments today. All right? So let's put this into play. Very quick, easy example is if I give you, a total number for all this, and let's say I make this whole thing 20. I tell you that AC is equal to 20, and you know what? I'm going to say when I broke this up, AB is equal to, let's go with 16. What would BC be equal to? Yeah, BC would equal to 4. Why? Because 16 plus 4 is 20, or 20 minus 16 is 4, however you want to practice. Okay. What I want to do today is give you guys some examples that are a little bit more challenging, and it could look like something like this. Right. So here's your segment CA. And CA is broken up into two components, so it's broken up into two segments, segment CB and segment BA. So I want to see the addition postulate being used here. So here's what I have. I have segment BC plus segment BA is equal to the total segment of segment CA. Okay. So I got these two segments that I split up, and I have segment CB here. I have another segment BA here in green, and then the entire segment in blue is that segment there. So what is segment CB again? What's segment CB? What expression represents segment CB? Yep.
2x plus 19.
Yeah, so segment CB is 2x plus 19 is just substituting in this expression. What is segment BA? What's segment BA in this one? Yep. Yeah, segment BA is this one here in green, x plus 19. So I gave you two expressions to represent each one of these segments, and then I gave you a constant of 14 to represent the total 14. And you write your equation off this way. Once you have this, then you construct a multi-step equation, which is your pre-algebra skills. Let's combine some like terms here. I got 2x and 1x. If I combine these two, I got 2 plus 1 is 3x. I got a positive 9 and a positive 9, which gives me a positive 18. And all this is equal to 14. Oh, and you know what? Quick little mistakes here. I wrote 9 and 9. It should have been, 19 and 19. Which doesn't give me 18, it gives me 38. Good. So, little mistake there. So 2x, 1x, 3x, 19, 19 is 38 equals 14. Okay, so now we combined our like terms. Nothing to do on the right-hand side, makes it even easier. I don't want 3x plus 18, I just want 3x. How do I get rid of that positive 38? Good, I'm going to subtract 38 from both sides. Bring down my 3x. And then I have 14 minus 38, or 38 minus 14, however you want to look at it. What's 38 minus 14? 38 minus 14, I got 24, so 14 minus 38 is negative 24. Last but not least, I don't want 3x. I simply want 1x. So how do you get rid of this 3 times x? Yep.
3x equals negative, x equals negative.
Good, so I'm going to divide both sides by 3. 3 divided by 3 is 1, or 1x, and that's always my objective or my goal, to get 1x by itself. And then negative divided by positive, I'm going to think about my signs first. And negative divided by positive is a negative. And then 24 divided by 3 is 8. I always focus on my signs first because that's the easiest part for me personally to miss. I know what 24 divided by 3 is, and if I don't know, I can easily put that in my calculator as well. But the negative sign and the positive sign somehow disappear. So worry about the sign, get that answer down first, solve for your equation. So now I have the answer of x equals negative 8. What do I do with it? So the question could say, find x. Done. No more. I'm done. Call it a day, move on to the next problem. Find x, and it could also say, find, what are your two segments? Segment CB and segment BA. Segment BCB was 2x plus 19. How do I find segment CB now? I have the expression that represents segment CB. I solve for x, which is equal to negative 8. One last step. Substitute your negative 8 in for x. So you have 2 times negative 8 plus 19. 2 times negative 8, negative 16, negative 16 plus 3, and you get, I'm sorry, negative 16 plus 19, and you get an answer of 3. Same thing for BA. BA was expressed by, the expression was x plus so BA again was x plus 19. Substitute in negative 8 for x. And negative 8 plus 19, and you get an answer of 11. Just for fun, what is 3 plus 11? 14. What was the total line segment? Just to verify you're doing it correctly. Next example, I got segment CE made up of segment CD and segment DE. So I'm just going to write segment CD plus segment DE is equal to segment CE. What's the expression to represent segment CD? My expression for segment CD. Yep. Good. 2x plus 22 is CD. What's my expression for DE? What's my expression for DE? Okay. Expression for DE is here, so plus 11. And then the last one here is the expression for all of CE, which is equal to x plus 25. A little more challenging than this one because you have variables on both sides of the equation, but nothing too crazy, okay? So before I start moving anything around, I'm always looking to combine like terms first. What's on the left-hand side of the equation? I have 2x, 22, and 11. Let's combine my 22 and 11 here, and I get 2x plus 33 equals x plus 25. You can shortcut this any way you want. I'm going to take the steps to show you guys all the steps behind this, okay? I'm going to bring this 1x variable over to the left by subtracting 1x from both sides. So now I have 2x minus 1x, so x plus 33 equals 25. One more step. Out of 1x plus 33, I want just x. Get rid of this positive 33, bring it to the other side by doing the opposite. Subtract 33 from both sides. And you get x is equal to 33 minus 25 is 8. 25 minus 33 is negative 8. So x is allowed to equal a negative number. Your line segments should come out to be positive, right? You're measuring the distance of them, and the distance is going to be positive. So I have negative 8 here as my x. I have CD, which we said was CD was equal to 2x plus 22. Substitute in my 8 here, or my negative 8, so 2 times negative 8 plus 22. 2 times negative 8 is negative 16 plus 22. And 22 minus 16, and again, answer of 6. So segment CD, 6. And again, you can plug these right into your calculator if you want. So I have segment CD is 6. This one's 11, and you could now here you have a choice. To get segment CE, you can either plug in -8 in for x, or you can just add 6 plus 11 and get 17. You have a choice here. I would probably check both. I would probably just plug into x to make sure it makes sense, but it's up to you. Okay? If you feel very confident on what you did for CD, great, stop there. Use what you know already to find the missing